In this video, I'm gonna go over this organic chemistry molecule. Here we have a benzene. And the first reagent here, we have this acyl group. So this is specifically an acyl halide with the Lewis acid catalyst AlCl3 and second step H3O+. So to start with predicted product, we can quickly substitute this chlorine with the benzene here, and we could choose any carbon of the benzene here because there is no directing group. So we can, let's say, add it on this carbon like this, where we add a benzene here, and we add on the acyl group onto that benzene ring at that carbon right there, where the chlorine is substituted with this hydrogen of the benzene right there. Now, for predicted product, here's the first step. The first step is to generate the good leaving group. So to do that, we're gonna have the acyl halides chlorine attack the aluminum and give us this intermediate here, where this aluminum with four bonds would be negatively charged, and this chlorine with two bonds would be positively charged. And this entire species here is going to be considered our good leaving group, which if it leaves away by itself first, we are going to form our strong electrophile, which is going to be our acylium ion here, where we see that we could do resonance by pushing a pair of electrons on this oxygen down to create that triple bond right there, which would give us this acylium ion here, which this would be the major resonance contributor because every single atom here has a full octet rule, even though this oxygen has a positive charge, right? But the electrophile is this carbon right here of the acylium ion, right? Which is going to be our electrophile. Then, once we formed our strong electrophile, the second step is to have the nucleophile, which is the benzene here, attack our electrophile. So let's draw in our major resonance contributor of the acylium ion, and I'm gonna dot that carbon, which is our electrophile, star this carbon, which is our nucleophile, attack, push the bond onto the oxygen, give us this intermediate here, where this is going to be the starred carbon, this is the dot carbon, this is the new bond between the star and dot carbon, using this bond right here, which is why this carbon here would be positively charged now because it lost the bond, right? If I were to highlight this bond in purple, that bond in purple is this new bond that we formed between the star and dot. And we said that this dot carbon here has an isopropyl group, and it used to be triple bonded to an oxygen, but now it's double bonded to an oxygen, right? Now, this is where we broke the aromaticity of the benzene ring, but we can restore that aromaticity by you doing elimination mechanism, right? So we see there's a proton here, which I'm going to draw out explicitly, and the base I'm going to use is this AlCl4 minus, right? Where one of the chlorines here is going to grab that proton and regenerate the aromaticity of this benzene ring right here. And we also reformed our acid catalyst. And a side product or a byproduct would be HCl acid, right? But we don't stop here because this carbonyl oxygen here is nucleophilic, which can attack the aluminum of the Lewis acid that we reformed, right? Because there is an empty p orbital there. And as a result, we're gonna get this intermediate here where we have the carbonyl oxygen attached to this aluminum, where the aluminum will be negatively charged with four bonds and oxygen will be positively charged with three bonds, right? Now that's the end of the first step. The second step is going to be an acid workup, so we could dump in hydronium ion, which will clean up the reaction and neutralize it, giving us this acylated benzene group and ions right here, right? This will dissolve into ions with the acid workup, which this will give us our final products here.